Yeah, thank you. And welcome to the GATE Academy. I'm welcoming you all to this GATE Score Booster session on the subject design of steel structures. We have already completed GATE Score Booster sessions on the subjects design of reinforced concrete structures and structural analysis. And of course, the GATE Academy have been completed or conducted GATE Score Booster sessions on almost all the subjects of various streams, right? So if you are new to this platform, you can go to our YouTube channel and watch those live sessions after the session. We have conducted GATE Score Booster sessions on almost all the subjects, and still we are conducting this. Okay, and this will be very useful for you. In this session, we are going to discuss design of steel structures as a part of this ongoing GATE Score Booster sessions. And in this session, I am planning to discuss almost all the important concepts or very important concepts of subject design of steel structures from exam point of view. Okay, so as you know, subject design of steel structures is having a less weightage compared to the other subjects like geotechnical engineering or environmental engineering, transportation survey. Comparing to other subjects, the subject is having a less weightage comparing to that. But we are focusing on scoring as maximum as possible in the GATE exam. So studying every subject is important. And of course, this is a subject where if you focus on certain topics, if you are getting a question from that topic, you will be able to score that marks. That's for sure. Right? What I'm trying to say is, if you are getting a question from steel structures, and if you have put some effort in learning the subject, it will be very easy for you to get the marks in that particular questions, unlike two other subjects. Okay. So myself, Abhin Srigandan, faculty here at the GATE Academy. Let's start without wasting much time. You can see Vamshi, Rahmat Ibrahim, and Anaga Pisharedi is there, and Krishna is there, Musa Jand is there. Yeah, I can see still people are joining. Those who have joined the session, you can just show your presence by saying a hi. Right? Hi Chandan, good afternoon. Good afternoon. Yes, good afternoon, everyone. I think we can start the session, right? Yes, with your permission. Let's get started the session with this topics. Before starting the session, let's have a glance at the topics we have to study in design of steel structures. Of course, we will start the subject with the introduction part, right? Introduction to steel structures. What we have to study there in steel structures. What are the topics there in steel structures? Or what is steel structure? Why steel has gained that much popularity as a building material? All these things will be discussed here. Okay? And what are the design methods? We know limited set method of design is there, and working stress method is there. All these things are there. All these things will be discussed here. It's important actually. Why? Because this gives the basics to the remaining chapters, right? We have the second chapter. I will tell you this. This is the most important chapters among the topics you are seeing here on your screen. Design of connections. We have to make some connections, right? We'll be having the materials. So we will be having the column. We'll be having the beams. We will be having different steel sections, and we have to connect them. How we can connect them? We can connect them by means of bolted connect bolts, or we can connect them by using riveted connections. We can connect them by using welded connections, or sometimes we may need bracket connections as well. So different types of connections are there: bolted, welded, riveted. Different kinds of connections are there. And in this chapter, we have studied, or we will be studying, or we have discussed how to design a connection, like a bolted connection, how to design a bolted connection, or what are the different type of connections, like lap joint is there, butt joint is there. All these things are there, right? And similarly, we have studied how to design a welded connection, fillet weld, butt weld, slot weld, and plug weld. All these things are there. And we have studied how to design bracket type connections, right? Bracket type connection one and type 1 and type 2. All these things are there in this chapter. Very important. Why? Because I'm talking from the GATE exam point of view. If you see the previous year question paper, you can see many questions are there from this particular topic. Last year there were no question from this topic, but maybe due to that we can expect a question this year. Okay, don't forget to revise this topic. And of course, third and fourth topics: design of tension members and design of compression members. Here, of course, we'll be discussing how to design tension members and compression members. What are the design parameters? How IS code is helping us to design the tension members and compression members. What are the cordal recommendations? All these things will be discussed here. from the GATE exam point of view, this is also important, especially the codal recommendations, the recommendations given by the IS code for the design of tension members and the compression members. And coming to design of beams, plate girders, and gantry girders, again, I will tell you this, it's a less important topic, but from the codal recommendations, from the IS code specifications, we can expect some questions. Okay, just go to the theory part. That will be enough, I think. And coming to, again, just like our design of connections, just like I told you, design of connections. Similarly, we have, again, one of the most important topic here in this subject, design of steel structures, from where we'll be getting questions for around 1 to 2 marks for sure. Plastic analysis of beams and frames. See, in structural analysis or in design of reinforced concrete structures, everywhere we were discussing about the elastic analysis, but this is a contradiction. Like here we'll be discussing something called plastic analysis. In elastic analysis, we were using structures up to its elastic limit, right? So here we are trying to use the entire capacity of the members. Very, very important. If you see the previous question paper, you can see many number of questions from this topic. If you master this topic, which will not take that much time, you will be getting that 2 marks or 3 marks, which is going to be there in the examination. Sure, short question will be there. Okay, so keep these things pointing in your mind. And this session, some of you are asking me, Bharat, we're asking, sir, is it a full revision session? Bharat, what I'm trying to do here is I have selected some questions as always, and with these questions, I will try to cover as many important concepts as possible. Okay, with those questions. And while discussing a question, I will try to mention the related topics as well, important related topics as well. We'll be discussing all these things. Okay, so I think we can start this session. We have not started this yet, right? Let's start this session with this question. Okay, as I used to say, those who have attended structural analysis and RCC, as I used to say this, first of all, you need to understand the question properly, right? In order to understand the question properly, you have to read that question properly first. Okay, go to each and every word given there, understand what is given in the question, try to understand it, and try to understand what he is asking us to find, and try to think how you can approach this question. And of course, options are also there. You have to identify whether it is an MSQ question or MCQ question. It will be mentioned in the GATE examination, but still you have to confirm this. Okay, yes, go for it. Read the question properly. I want each and every one of you to read the question properly, and I will give you some time, maybe 30 seconds, not more than that. That time is given only for understanding this question. Okay, I want you people to try to solve this question, and after that I will also help you in solving this. Okay, read the question properly, read it, each and every word, read between the lines, understand what is given, understand what he is asking us to find. Do not skip or do not leave any word. Okay, there may be your answer will be there in that word maybe. Okay, so focus on the question. Angit, don't skip this subject. If you are confident in other topics, you can still watch this GATE Syllabus sessions. At least you can go through these questions. Okay, I will be helping you. I can assure you that. Yes, Manoj, good afternoon. And Mahadeva is telling, yes, this is an important session. So of course, it will be helping you a lot. For this question, Angit Kumar is asking the same question. Okay, fine. Okay, very good. So I think let's read the question properly first. Let's try to understand what is given in the question. It is saying that a 8 mm thick angle section, we are given with an angle section, is connected with 10 mm or connected to a 10 mm thick gusset plate. Okay, this is gusset plate, and we are given with an angle section also. This angle section here is connected to 8 mm thick angle section here is connected to a gusset plate of thickness 10 mm. And it is also saying that angle is subjected to a design load of 250 kilonewton. Remember this, it is given that it's given with a design load of 250 kilonewton. And it's also saying that assume shank intercepts the shear plane. Those who don't know this, don't worry, I will explain that. And it is also saying that FUB and FU is also given there, that is 400 Newton per mm square. KB value is also given there, that is 0.5. And he is asking us something here. What is it? Which among the following statement or statements is or are correct? So what kind of question is this? Is it an MCQ question or MSQ question? Of course, it is an MSQ question. Of course, it will be given in the question itself. So let's read the options. Design shear strength of the bolt is 58.04 kilonewton, and design bearing strength of the bolt is 53 kilonewton, and design strength of the bolt is 53 kilonewton, and number of bolts required for the connection is 5. So these are the things given in our question. Okay, these are the things given in our question. Yes, Krishna is asking for bolt diameter. That data is missing here. You can do one thing. You can assume M20 grade bolts. Okay, otherwise you can say diameter of the bolt here is 20 mm. Fine, Krishna. This data is missing in the question. You can just make the correction there. Right, M20 grade bolts or diameter of the bolt is around 20 mm. Fine, Krishna. Okay. So let's go with options by option, one by one. Let's go with the options. First one is design shear strength of the bolt is 58.04 kilonewton. Tell me, is it correct or wrong? What about that statement? Or how to calculate the design shear strength of the bolt? Let us start with that then. First of all, we need to calculate the design shear strength of the bolt, right? Design shear strength of the bolt. How to calculate the design shear strength of the bolt here? I'm going to denote it with the letter VDSB. How to calculate it? Nominal shear strength of the bolt divided by gamma MB, where gamma MB is the partial safety factor for the material, that is bolt, right? So we know how to calculate the nominal shear strength of the bolt, or I will write the equation directly. FUB divided by √3 gamma MB into NNA and B. I'll tell you what are they, plus NSASB. So this is the equation given in our IS code for calculating the design shear strength of the bolt, right? Can you tell me what are these terms? What is FUB? Anyone? What is FUB? FUB represents, or FUB gives the ultimate tensile strength of the bolt, right? Yes. What is the value of gamma MB? Exactly. What is the value of gamma MB? FUB in the question itself, it is given that 400 Newton per mm square. Of course, it is 400 Newton per mm square. And divided by √3. Wherever there is a shear capacity, this √3 term will be there in almost in every cases, right? What is gamma MP? Is it 1.25 or 1.5? Tell me this. Is it 1.25 or 1.5? Okay, I need your answers, confirmation on this. I'm getting different answers here. Some of you are telling me like 1.5, 1.1, 1.25, 1.25. It is 1.25. Yeah. For bolts, whether it is workshop or in the field, the gamma MB value, the partial safety factor for bolt material will be 1.5 only. But for weld, it will be somewhat different. For what is the value of gamma MW there? For weld, partial safety factor for material for welded connection, it is 1.25 and 1.5 for workshop weld and site weld. Yes, exactly. Yes, that will be the difference there. And what is this NN value? Anyone? Here in this equation, yeah. What is NN value? Anyone? What is NN value? NN is actually, yes. NN is actually the number of shear planes, with or without thread. Number of shear planes with or without thread. Tell me this. Number of shear planes with thread. Number of shear planes with threads intercepting the shear plane. Intercepting the shear plane. This is the value of NN. This is what is our NN value. Tell me what is NN value here? NN value here. What is NN value here? Is it 0 or 1? Is it 0 or 1? NN value here is 0, right? What is NN value? Yes, I will come to this. What is NS value? Number of shear planes. Number of shear planes without thread. Number of shear planes without thread. Without thread intercepting the shear plane, right? Intercepting the shear plane, right? So what is the value of NN and NS here? Tell me this. What is the value of NN and NS? Tell me this. Yes, the value of nn here will be 0 and value of nsb will be 1. Why it is 1 and 0? Why? Because here it is given that the shank intercept the shear plane. What is the meaning of it? What is the meaning of it? Here we are having the bolt like this. We will be having the bolt like this, and this will be our shear plane, right? And it is saying that this shank intercepts the shear plane. This will be our thread. Somewhere here we'll be having your thread here, right? Shank intercept our shear plane. So ns here will be equal to 1 and nn here will be equal to 0. That's the value of it. And there we are given with a and b and asb. What is a and b? We need to remember this. What is a and b? A and b here is the net area of the bolt, right? What is a and b? Net shear area of the bolt, or we can consider it as 0.78 into or pi by 78% of gross area of the bolt or shank area of the bolt, right? Pi by 4 into d square. That is a and b. And ASB, that is shank area, we can consider it as pi by 4 into d square. So this is what is the area of the shank. So we can consider this as 0, and remaining ns will be equal to 1 and ASB will be equal to pi by 4 into 20 square. Tell me the value of value here. I'm getting your answer here. I'm seeing your answers here as 58.04, something like that. 58.04 kilonewton. I am assuming that this is the answer, as I'm getting this as an common answer, right? So 58.04 will be our design shear strength of the bolt. So option A is actually a correct answer. Option A is actually a correct answer. Tell me about the option B. Let's go with option B, design bearing strength of the bolt. Tell me the equation for calculating the design bearing strength. How to calculate the design bearing strength? How to calculate the design bearing strength of the bolt? What is the equation? Design bearing strength of the bolt. How to calculate the design bearing strength of the bolt? How to calculate it? Tell me the equation for calculating the design bearing strength of the bolt. Exactly, right answer. Design bearing strength of the bolt. Of course, it will also be, I'm going to write it as BDPB will be equal to VNPB, that is nominal shear, bearing strength of the bolt divided by, let us say, gamma MB, which will be equal to 2.5 kb dt into fu divided by gamma mb. This will be the equation for calculating the design bearing strength of the bolt. Correct? This will be the equation for calculating the design bearing strength of the bolt. What are the details given there? Kb value. What is the kb value? How to calculate the kb value? Kb value here in this question is given as 0.5. But what if it is not given? Exactly, Mahadira, right? Yes, how to calculate the kb value if it is not given? Kb value is actually, it will be the smaller value of what? Smaller value of E divided by 3 times the dh. Dh represents the diameter of the hole, or P divided by 3dh minus 0.25, or it is the ratio of FUB divided by FY, or finally it will be ultimately it will be equal to 1, right? We have to take the minimum. In no case it should be greater than 1. That's the meaning of it, right? So what is the E value? What is E value? Exactly, Mahadeva. Let's see that. So what is E value? Yes, right, very good. So what is the DH value? DH value represents the diameter of the hole, right? DH here represents the diameter of the hole. How to calculate the diameter of the hole here? In order to calculate the diameter of the hole, IS code is giving us some equations, right? Diameter of the shank diameter plus 1 mm, shank diameter plus 2 mm, and similarly shank diameter plus 3 mm. When we will consider this, for what range of diameter we will be considering this? I need your answers. When the diameter of the hole is equal to diameter of the shank plus 1, when the diameter of the hole is equal to diameter of the shank plus 2, and when it is diameter of the shank plus 3, I will need your answers here. Exactly. When the diameter of the shank is between, exactly, it is 12 mm to 14 mm, it is diameter of the shank plus 1 mm, or when it is from 16 mm to 24, right? Yes, 16 mm to 24 mm, it is diameter of the shank plus 2. And when we will be considering it as 3, exactly, when the diameter of the shank is greater than or equal to 27 mm, it will be considered as diameter of the shank plus 3. Very, very important, super important. You have to remember this. And similarly, how to calculate this p value? What is p value? What is p value here? Tell me what is p value? Exactly. What is p value? P value is the center to center distance between the bolts measured in the direction of the stress or measured in the direction of load, right? And we have some equations for calculating the pitch value also. And how to calculate this FUB value and FY value? How to calculate this FUB value and FY value? How to calculate this FUB value and FY value? Anyone? How to calculate it? We know this, right? How we will be representing the bolt. Bolts are usually represented somewhat like this, M D by L, right? When you are given with something like this, what is the meaning of it? Can anyone tell me this? Suppose you are given with something like this, M16 divided by 70. What's the meaning of it? Anyone? What's the meaning of it? This is how we will be representing a bolt, right? Bolts are usually represented somewhat like this, M D by L. What's the meaning of this? What is the meaning of this M? What is the meaning of M? M represents our metric size, right? And what is D? D represents the shank diameter, right? D represents the shank diameter. What is L? What is L? Anyone? What is L? Anyone? Sorry. What is L? Anyone? I'm seeing your answers. Yes, L represents the length of the bolt. Length of the bolt. Here shank diameter is, for example, yes. Here shank diameter is 16 mm. Here diameter of the bolt here is 16 mm and length of the bolt here is 70 mm. That's the meaning of it. Sometimes bolts will be given with some grade. Suppose if I am saying that grade of the bolt is 4.6, I need to tell you, I need you people to tell me what is the meaning of this. What you mean by grade of the bolt 4.6? When you say grade 4.6, what do you mean by that? Anyone? What is this 4.6? Anyone? What we are understanding from here? Sometimes see, yes, exactly. This 4 here represents FUB divided by 100. Or I can say, yes, exactly. I can say if you multiply this number, the number which is just before the decimal point, if you are multiplying it with 100, I will be getting the FUB value. FUB value here will be equal to 400 MPa or 400 Newton per mm square. What is this 0.6 or 6 value? This 0.6 represents the ratio of FYB to FUB. What is this? Which means that FYB here in this case will be equal to 0.6 times FUB. What's the meaning of that? 0.6 times 400, it will be equal to 240 MPa. That yield stress of that that bolt will be equal to 240 MPa. That's the meaning of it. Similarly, you can consider grade 8.8 also. What is grade? What is the representation? This what do you mean by this? Grade 8.8? Yes, you tell me this. What is the meaning of grade 8.8? Tell me the value of FUB and FYB. What is FUB and what is FYB? I need you to understand this. Exactly. FUB here will be equal to 800 MPa. What will be FYB? FYB here will be equal to 640 MPa. That's the meaning of it. Right? Just try to remember this. There was a question in GATE exam. This was a GATE question, right? M16 divided by 17. What's the meaning of this? Options were given. Shank diameter is 16 mm. Cross section of the bolt is 16 by 70 mm square. Diameter of the bolt is 70 mm. Some options were also given there. So understand the meaning of this. Okay, very important. And coming back to a question, here we are asked to calculate the design bearing strength. We know the value of KB. What is the value of KB? KB value here is 0.5, which is already given in the question. Sometimes in some questions it will not be provided. In some questions this KB value will not be provided. In that case, all the other details will be given to you. E value will be given, DH value will not be given, but diameter of the bolt will be given. From the diameter of the bolt, from this data, you need to calculate the diameter of the hole, right? And calculate the diameter of the hole, get the values here, and of course get the smaller value to find as the KB value, right? And similarly, we have D and T. Tell me the value of D, T, Fu and gamma MB. Let's calculate the design bearing strength together. Right. So we are interested in calculating the design bearing strength of the bolt. Right. Design bearing strength of the bolt. Right. It is represented by VDPB. Design bearing strength of the bolt. Right. VDPB. Tell me the value. 2.5 into KB value is obtained as 0.5. Diameter of the values, bolt is 20 divided by, and we have gamma MB value. Gamma MB value is 1.25. What are the remaining terms? I need the value of T and I need the value of Fu. Tell me the value of T and Fu. Tell me the value of T and Fu. I need you people to give me the answer for this. Tell me the value of T and Fu. Tell me the value of T and Fu here. T and Fu. Tell me the value of T and Fu. Yes. Yes. T is the thickness, right, of the smaller member. That is 8 mm. Fu value here is, of course, it is 400. Get me the answer here. That's it. Get me the answer here. VDPB. Design bearing strength of the bolt. What is the value? Exactly. I'm getting the answer here as 65.6, right? Yes. I need you people to confirm this answer. I need you people to confirm this answer. What is VDPB? What's the answer we'll be getting here? I'm getting the answer from Mahadeva. Very good. I appreciate that. What is the answer here? What is the answer here? Yes, answer here. I need your answers, please. I need your answers, please. Yes. I'm going with Krishna's answer. It is 65.6 kilonewton. I'm going with Krishna's answer, 65.6 kilonewton. Fine. So this is the design bearing strength of the bolt. Yes. I think this is 410, right? Yes. Small mistake is there, right? Yes. Is it 410 or 400? Let's correct this first. Is it 410 or 400? Is it 410 or yes, Gursaj? Yes, Gursaj is asking for 1.5 or 1.25. Gursaj is asking for it is 1.25 or 1.5. See, it is 1.25. For bolt, it is 1.25 always. For workshop or site, it is 1.25 only. Yes. So this will be the answer, 65.6. Got it? So this is the bearing strength of the bolt, right? Design bearing strength of the bolt. From this, we can easily calculate the design strength of the bolt. How to calculate the design strength of the bolt? Yes. Very good. So how to calculate the design strength of the bolt? How to calculate it? Yes, we need to calculate the minimum of these two. Design shear strength of the bolt and design bearing strength of the bolt. Which one is the minimum? Which one here is the minimum? Which one here is the minimum? Design shear strength is obtained as 58.04 and design bearing strength is obtained as 65.6. So I have to take the minimum of 58.04 and 65.6 kilonewton, right? So which one is the minimum here? 58.04 kilonewton is the minimum. So this is the design strength of the bolt. So once you go with the options, we need to check the options, right? So option B, is it correct or wrong? Design bearing strength of the bolt, is it correct or wrong? Design bearing strength of the bolt is not 53, it is somewhat around 65.6. Design of the bolt is the least of these two. The least of the values were 58.04. So this is also wrong. Now it is asking us to calculate the number of bolts required for the connection. How to calculate the number of bolts required? Anyone? How to calculate the number of bolts required for the connection? Anyone? Number of bolts required here. How to calculate the number of bolts required? Anyone? Yes, exactly. Design load divided by design strength of one bolt, or let us say bolt value, whatever it is, right? So design strength of the bolt. Design strength of bolt. We know the design load is around 250 kilonewton. Design strength of the bolt. What is the design strength of the bolt? It is 58.04 kilonewton. Let us convert it into meters, right? Sorry, newtons. So what is the answer? What is the answer? we are getting it as 4.3. So how many bolts are required here? 5 number of bolts are required here. 5 number of bolts are required here. So let's go with option D. Option D here is the correct answer. So as it is an MSQ question, exactly, as it is an MSQ type question, we need to report our answer like this, right? So we need to select option A and D as the correct answer here. We need to select option A and D as the correct answers. Okay. So this will be the design strength of the bolt. Sorry, this is the answer for this particular question. The design strength of the bolt here is 58.04, and the number of bolts required for this connection, where angle connection is 8 mm thick angle is connected to the cassette plate, right? So for this connection, we need a minimum of 5 number of bolts. Okay, so that's the end of this solution, right? So let's go with one more question from this chapter. Go to this question, please, everyone. It's very, very important, super important concept. Just go to this. And again, I will tell you this. Understand what is given in the question. Try to understand that first and understand what he is asking us to find. What he is asking us to find and what he is given in the question. Read the question properly and try to get me the answers. Read the question properly and try to get me the answers. Read the question, each and every word. Right? You should go through each and every word given there. Read between the lines. I need you people to give me the answer here. Go for it, please. Go for it. I'll give you time. 20 more seconds. I need you to give me the answer here. Even if you don't give me the answer, it's fine. But I need you people to understand it, understand the question. I need you people to try this question at least. Right. Getting the answers. Okay. Tell me this. What are the forces which will be there acting on this bolt? You can see the bolts here, right? This is actually a bolt. This one here is a bolt. This is the bolt, right? These are bolts, assume like that. What are the forces which will be there, which will be acting on this bolt? Is it tensile forces or something like that, something else? What are the design forces which will be there in that bolt, which will be acting on that bolt? Anyone? The design forces acting on that bolt. Anyone? Anyone? I'm seeing your comments. Anyone? What are the forces acting on the bolt? I need your answers, please. What are the forces acting on that bolt? I mean, on that bolt. I'm taking this figure here. But before that, I'll read the question for you once. There are 4 bolts sharing the load P shown in the figure below. Yes. There are 4 bolts sharing the total load P. This is the total load acting on this bolt. Exactly. It is shown in the figure below. The shear strength of the bolt is 50 kilonewton and the tensile strength of the bolt is 100 kilonewton. The value of P is, that's what we have to calculate here. And we have to report our answer in here. We are not provided with any options, so it's a numerical answer type question. So first of all, we came to know that there are 4 number of bolts, which we cannot understand it from the figure, right? So there are 4 number of bolts and total load acting on the connection is P, and shear strength of the bolt is also given. Shear strength of the bolt is also given 50 kilonewton and tensile strength of the bolt is also given, that is 100 kilonewton. We need to calculate the value of P. The value of P has to be calculated from this question, right? Yes. Yes, Mahadev is giving me the answer. Perfect answer. So what are the forces which will be acting on this bolt? If you see this P force is acting at an angle 45. So which means I can resolve it in 2 components. This one will be P. Let us say I'm going to call it as P sine 45 as the angle is 45. The sine or cos doesn't matter actually here. But this is this angle. I'm taking this angle here. So this one here will be equal to P sine 45. This P sine 45 will be causing tension in the bolt, right? Yes. Similar to that, I can consider force in this direction also. What is this force? This is P cos 45. Exactly. Now tell me, this will be causing tension and 1 second. this force P sine theta sine 45 will be causing tension, and this will be causing shear. So we have studied this when bolts needs to be designed or needs to be resisted or needs to resist shear and the tensile force. We need to satisfy one condition. Can anyone tell me what is the condition to be satisfied when the bolt is subjected to both tension and shear? When the bolt is subjected to shear and tension, one condition has to be satisfied as per IS 456-2000. What is the condition? Anyone? It is VSB divided by VDSB, one second, the whole square plus TB divided by TDB, the whole square. Yes, less than or equal to, what is the value here? I'm getting the answer here as 0.7, right? So less than or equal to, is it 0.7? No, it is 1.0. So this is the condition that must be satisfied when bolts are subjected to both shear and tension. Exactly. This is the condition that has to be satisfied when the bolts are subjected to tension and shear. You need to remember this, very, very important. There is the 2 questions from the GATE exam. You can remember this, very, very important, right? VSB. Tell me what is the value of VSB? Anyone? I need you to give me the value of VSB. What is VSB? It is the factored shear force acting on the bolt, right? Factored shear force on the bolt. And what is VDSB? It is a factored, sorry, let us write TB there. What is VSB and TB? What is TB? TB is the factored tensile force. TB represents the factored tensile force. Factored tensile force. I'm writing TF here only. I'm writing only TF here. TF or tensile force on the bolt. And similarly, you can tell me what is TDB and TDSB. What is TDB? Anyone? It is design tension capacity of the bolt. Design tension capacity of the bolt. Design tension capacity of the bolt. VDSB is actually the design shear capacity of the bolt. Design shear capacity of the bolt. I need values of VSB, TB, TDB, and VDSB. First, tell me what is the value of VSB? Anyone? What will be the shear force on each bolt? Total shear force. What is the total shear force? What is the total shear force? Exactly. Total shear force here is P cos 45. How many bolts are there? 4 bolts are there. Or I can write it like P by 4 root 2 is the factored shear force acting on the bolt. Can I say like this? Anyone? Or no? Yes. Similarly, factored tensile force on each bolt. Total tensile force here is P sine 45. P sine 45 divided by 4, which will give you the value, that is factored shear force there. P by the factored tensile force there, that is also P by 4 root 2. Give me the values here. What are the values? What are the values? Design tension capacity and design shear capacity. What are the values there? What are the values there? I'm seeing your comments. What are the values? The design shear capacity is 50. Design shear capacity is 50 and design tension capacity is 100. Sorry, it is not root 4, it is root 2. Thanks for that. Thanks for the Gurzash. Very good. So design tension capacity is 100. Design tension capacity is 100 and design shear capacity is 50. Yes. Now all the things are available in front of you. Now all the things are available in front of you. What we are asked to calculate? What we are asked to calculate? We are asked to calculate this P value. How to calculate it? Get all the details in this equation. Put all the values here in this equation. Get me the value of P. Get me the value of P. Try this question now. Try this question right now. Put all the values. VSB, that is P by 4 root 2 divided by 50 the whole square plus TDB. Sorry, TB, that is also P by 4 root 2 divided by TDPB, that is 100 the whole square less than or is equal to 1.0. And this is the only one unknown here is P value. I need you people to give me the answer here. What is the value of P? Give me the value. Give you some time. Get me the value of P here. Give me the value of P. I'm seeing the answer as 8. Krishna, can you check your answer once? Krishna, kindly check your answer once. Yes, I will also help you. You can write it like P square divided by 4 square is 16, root 2 square is 2. So it can write like 32 into 50 square plus P square divided by 32 into 100 square should be less than or equal to 1.0. From this, I can write P square divided by 50 square plus P square divided by 100 square, which will be equal to less than or equal to 32. From this, I need the value of P. Anyone? You will be getting it as 353 point something. Right? Let us write it as 353 point something, and you can correct me if it is wrong. Okay, you'll be getting the P value here as 253.0 or 52.98. I am just rounding it off to 253. Okay, Krishna is giving me the correct answer. Thanks for confirming this, Krishna. 252.98, or I can say 253 kilonewton. This will be your answer. This will be the maximum value of P. Right. So ultimately, you have to remember this equation. This is what is important. This is what is important. Remember this equation. Very, very important. Remembering this is recommended. VSB divided by VDSB the whole square plus TB plus TB divided by TDB the whole square should be less than or is equal to 1.0. Right. In the previous code, it is somewhat different. Instead of this 1.0, it was 1.4. We are following IS code. I mean, limit state method right now. IS 800/2007. So as per this, we'll be following this equation, right? You can still find the previous equation in some materials and all. Don't follow this. This will be the equation I'll be using when the bolts are subjected to both tensile and shear forces. Got it? Yes. All of you are giving me the correct answer. Very good. Very good. Super. So remember this equation. Sometimes you will be getting the direct equations. Which among the following is the equation, the interaction formula? When one bolt is subjected to shear force and tensile force, whichever the following condition has to be satisfied, and you will be given with different equations. Sometimes VSB divided by VDSB the whole raised to 1/2 plus TB divided by TDB the whole raised to 1/2 less than or equal to 1.0. Some conditions, some different equations will be given, and you will be asked to choose the correct one among the following. Okay, so that's the end of that question. Very, very important, super important question. Right. So let's go with the next question. Go with this question, everyone. Again, follow the same procedure here. Follow the same procedure. Understand what is given in the question. Try to understand what is given in the question. Read the question properly first. It's a welded connection. Like the previous questions, here we are given with a welded connection. Right? Welded connection. Here we are given with a welded connection, and we are asked to calculate the service load per meter. Okay. So understanding the question is important. I will tell you, and I will tell you the possible mistakes you are going to make here, right? What are the mistakes you are going to make here in this question, right? So fillet welded connection shown in the figure, and I needed to calculate the service load. Yes, answers please. Assuming that you people are solving this, okay? I will read the question for you. Consider the fillet welded connection. So we are given with a fillet welded connection. It is shown in the figure. It is asking us to calculate the service load per meter. Remember, he is asking us to calculate the service load. Right? Yes. As per IS 800/2007 is equal to dash kilonewton. We have to report our answer in kilonewtons. Use Fe 450 grade steel, and welding is done on the site. Welding is done on the site. So these are the details given. Okay, I'll come to that. But before that, if you see the figure, you can see this is a fillet weld. We are given with the fillet weld here, just like even the question. But we are given a plug weld also. Right? We are given with plug weld also. What is plug weld? This is we will be providing a slot there, and we'll be welding it. Right? We'll be filling it with weld material. So this is a plug weld. And diameter of the plug weld is around 30 mm. We are given with a fillet welder connection along with a plug weld. And what we have to calculate, we need to calculate the service load which can be given, or the service load on the connection as per IS 456/2000. In order to calculate the service load on the connection, first of all, we need to calculate the design strength of the connection. Right? In order to calculate the design strength of the connection, we need some basic details. Right? like what is gamma MW value? You know that for site weld, it is given that it is the welding is done on the site. When the welding is done on the site, what is the gamma MW value? I'm seeing your comments. What is the gamma MW value? Anyone? What is the gamma MW value? I need your answers. Yes, exactly. Gamma MW value here will be equal to 1.5. Very good, very good, very good. Gamma MW value will be equal to 1.5. Very good, Krishna. And what if the welding is done on workshop? If the welding is done on workshop, what will be the gamma MW value? Gamma MW value, what will be the gamma MW value when the welding is done on workshop? Exactly, it is 1.25. Very good, Krishna. Right. So we don't require it here. Why? Because the welding here is done on the site itself. So this is the details, one detail given in the question. And similarly, I may require the value of FU. For FU 450 grade steel, it will be equal to 410 Newton per mm square, right? And FU weld, I'm taking it as, and this is also I'm taking it as 410 Newton per mm square. You can assume it like this. Okay, you can take it like this for this question. And size of the weld, it is also given in the question. Size of the weld is also given in the question. It is given as 8 mm, right? Size of the weld here is given as 8 mm. I think it is not given in the question. Okay, it is not mentioned in the question. Yes, it is mentioned in the figure here, right? It is mentioned in the figure here. Size of the weld is mentioned in the figure here. That is mentioned as 8 mm. Very good. Sometimes you have to be very careful here, right? Sometimes it will not be given in the question wordings, right? Question statements, it will not be mentioned, but you will get the details there in the figure. So size of the weld here is given as 8 mm. And in order to find the design strength of the weld, especially the fillet weld, we need to calculate the throat thickness. How to calculate the throat thickness here? Tell me how to calculate the throat thickness here. S is the size of the weld. I am representing the throat thickness with the letter TT. How to calculate it? Exactly, it is 70% or 0.7 times the size of the weld. It will be equal to 5.6. It will be equal to K into S, right? So 5.6 mm. Now I think we are given with all the details to calculate the design strength of the fillet weld, right? So let us write it like this: design strength of the fillet weld. Design strength of the fillet weld here is equal to, how to calculate it? Length of the weld, exactly, then thickness of the throat into FU divided by, okay, sorry, FUB divided by √3 gamma MW, right? What is the length of the weld? You can see some of you are going to make the mistake here. This is 100 mm, right? Yes, exactly. So length of the weld is 100 mm. How many of you wrote like this? How many of you wrote the length of the weld as 100 mm? Anyone? Anyone? No, right, very good. So length of the weld here is not 100 mm. The length of the weld here is 200 mm. Why it is 200 mm? The fillet weld is provided here and here as well, right? So length of the weld here is 200 mm. It is not 100 mm. And again, thickness of the throat is 5.6 mm. And what is the FUB value? FUB value will be equal to 410 divided by √3 into 1.25. That is the gamma W value. So what is the value here? Tell me the value here. What is the design strength of the weld? Tell me the design strength of the weld. Anyone? Yes. This is a mistake. What is the mistake here? Even if we write 1.5 there in the question, we are habituated in writing 1.25. I have seen many people making this mistake, right? How many of you notice this? This is not 1.25. This is 1.5. In bolted connection, everywhere it was 1.25. Here in welded connection, for shop weld, it is 1.25, but for site weld, it has to be taken as 1.5, not 1.25. They common mistake students usually make, right? So I'm making this mistake for you people not to repeat this in the examination hall. Okay, so this is 1.5. So get me the answer here. Yes, I'm seeing the answer here as 176.746, right? You can correct me if it is wrong. 176.746. And Gushbu Joy is giving me the answer. Okay, thanks for that. 176.746 kilonewton is the design strength of the weld. Tell me, we are asked to calculate the service load per meter. Correct? How to calculate the service load per meter? Service load or working load per meter, right? Working load, per meter load, service load, per meter load or working load. How to calculate that? Design strength divided by partial safety factor. That is 1.5. I'll be getting the value. But is the solution completed right now? No, the solution is not completed. Why? If you see the connection here, it is not only the fillet welded. It's not only fillet welded, but it's also provided with plug weld. So this plug weld will also be providing some strength, correct? So when we are calculating the strength of the connection, we need to consider this plug weld also. I need to calculate that plug weld also. So let us calculate the design strength of the plug weld as well, right? Design strength of plug weld. How to calculate it? Anyone? Area of the plug weld? Anyone? Yes. Into the same thing, right? How to calculate the area? Pi by 4 into 30 square. Why? Because we are providing the plug weld only in this slot provided, in this provision provided, right? So pi by 4 into 30 square. 30 here is the diameter of the plug weld into FUB divided by root 3 gamma MW. All other details will remain as it is. Pi by 4 into 30 square into FUB, there is 410 divided by root 3 into 1.50 will be the design strength of the plug weld. Give me the value here. What's the value? It's just a matter of seconds. Yes, you will be getting it as Krishna is giving me the answer as 111.50 kilonewton. This will be the design strength of the plug weld as per Krishna. Others can confirm this. This is the design strength of the plug weld. Design strength of the plug weld. This one here is the design strength of the plug weld, and this one here 176.746 is the design strength of the fillet weld. Yes, thanks Kushpooja. Kushpooja is also still telling me the answer as in 111.554. Okay, very good. Then total design strength, or we can say design strength of the connection. Design strength of the connection. How to calculate it? Design strength of the fillet weld plus design strength of the, let's calculate as PDW, okay? PDFW of the design strength of the fillet weld, and PDPW is the design strength of the plug weld. Let us take the summation of those. 176 point, I think it was 746, right? Yes. 176 point, yes, 176 point, exactly. 176.74 kilonewton. Plus plug weld was 111.54 kilonewton. If you take the summation of these two, what's the answer you are getting? I'm seeing the answers here. I want to see the answers here. 287, right? 88 point something will be the answer. 8, right? You can confirm this answer. This will be the design strength of the connection. Almost 288.8 something like that, right? This will be the design strength of the connection, but we are not asked to calculate the design strength. We are asked to calculate the service load permitted, right? Service load which can be permitted, or permitted load which can be permitted on this connection will be equal to 288.28 divided by 1.5. What's the answer here? What's the answer here? Krishna was giving me the answer, that is 192.19 kilonewton. This will be the service load that can be permitted. Did you get the point? Sometimes they will stop the question here. Sometimes they will simply ask you what is the design strength of the connection. They will simply ask you this. They will not ask anything further. Sometimes they will ask this question to calculate. They will extend the question to calculate the service load. In that case, this 1.5 will not be given in the question. You should be knowing this, right? Calculate the service load. You have to divide it with 1.5. You'll be getting the answer here as 192.19 kilonewton. This will be the answer here. Right? This will be the answer here to this question. 192.19 kilonewton. The point. This is how we'll be calculating the design strength of the weld. And remember, some similar kind of questions are there in GATE exam as well. You can just go through the previous GATE question papers, right? It's very simple, right? It's a pure logic. Area into strength. I will be giving the design strength. LWDT in case of fillet weld, and the area of the plug weld into that FUB divided by root 3 gamma MW will be giving you the design strength of the plug weld. Take the summation of that, and you'll be getting the design strength of the connection. Divide it with the partial safety factor, and you'll be getting the design strength. Yes, not yet, Krishna, but we can expect it. We can expect it in the coming exams. Sometimes you'll be given with slot weld also. And then if you are given with slot weld, things will be somewhat different. You can just find it yourself, right? We can expect plug weld this time. In float weld, we'll be providing the weld along the periphery. Okay, we'll not be providing it throughout, but we'll be providing it along the periphery. Remember this. Not important, just remember this. Right. And similarly, let's go with the next question. I want you people to try this. It's important. Read the question properly. Read the question properly. And here actually there is a small error. This is not 40 mm square. It is 40 centimeters square. Okay. Read it properly and get me the answers. It may take 2 minutes of your time. I'll give you 30 seconds to understand the question. Even if you don't solve this question right now, but I want you people to understand this question right now. Very important. What is asking in this question, and you have to think that there must be a thinking process, right? What are the details given? Understand that first, and you should understand how you can find it. That's what you have to do. Read the question properly. I will show you the figure also along with this question, so that it will be easy for you to read the question, understand the question. So all the details are given, right? All the details are given. It's an I section. This is actually not there, but even if it is there, you have to assume it like this. It's a nice section like this. All the details, all the units are given here in mm, but you can take the dimensions as per your convenience. It's actually as per your convenience. I need you people to calculate the shape factor. Okay, what are the things given in the question? Let's read the question first. Section shown in the figure below is symmetrical to its vertical axis. Okay, very good. Top flange is of 40 mm by 40 mm. Okay, top flange dimension is also given. Anyhow, it is available in the figure itself, right? Bottom flange is 160 mm by 10 mm. Here there is a small error. It is not 16, it is 160 mm. Okay, and this is also given 160. Bottom flange is 160 mm by 10 mm, and web is given as 10 mm by 80 mm. Fine, that is 1 centimeter by 8 centimeter. Area of section is also given. The entire area, total area given here is 40 centimeters square, and centroid of the section, so it is also given there in the question, just to reduce our load. I think it is also given that centroid of the section lies at 56 mm from the bottom of the section. Okay, fine. And what is the shape factor? So they are asking us to calculate the shape factor. They are asking us to calculate the shape factor. Okay, so this is the section given. This is the section given. Now I want you people to try this question. Give a try. Try to understand. We have understood the question. He has given us a section, and he is asking us to calculate the shape factor of this section. And you should know how to calculate the shape factor of a particular section. That's very important. If you don't know how to calculate it, there is no use of solving this question. Okay, you have to understand it first. Those who don't know what is shape factor, I can give you a brief idea about that, so that it will help you a lot in the examination. What is shape factor? Shape factor can be defined as the ratio of, I can say, shape factor is the ratio of, yes, shape factor is the ratio of plastic moment to yield moment. Plastic moment to yield moment of the section. I'm going to call the shape factor, I'm going to denote the shape factor with the letter, I can denote it with the letter AS, or I can write it like S. I'm going to denote it with the letter S or SF, will be equal to MP divided by My. We know My, or we can write it like yield stress, 1 second here, yield stress into plastic section modulus divided by yield stress into elastic section modulus. From that I can cancel these things out. It will come out to be ZP divided by ZE. But the same thing can be defined as, or I can say, shape factor. I told you it is a ratio of plastic moment to elastic moment. Or I can, right now I can say shape factor can also be defined as the ratio of plastic section modulus to elastic section modulus. Remember this, very, very important. If you know this relation, it is a matter of seconds. If you know this equation, it's a matter of seconds, but you need to remember this. You need to know this equation, right? Shear factor is equal to ZP divided by ZE, which is plastic section modulus and elastic section modulus. And I can extend the definition further. What is the definition? For what are the factors on which shear factor depends? We can say that it's a function of the shape of the cross section. Okay, it is a function of, or it is a function of shape of the cross section. Is the function of shape of the cross section, right? It represents the strength of the material beyond the yield point, right? It represents or it's a measure of reserve strength after initial yielding. I can write it in that way also. 1 second. It is the measure of reserve strength after initial yielding. Give me 1 second here. Yes, after initial yielding. So we have denoted the KP value or KS value or shear factor value as the ratio of ZP divided by ZE. At the end of the day, you need to remember only this. You need to remember only this. Shear factor is equal to ZP divided by ZE. First of all, what is this ZP and what is ZE? Anyone? What's ZP? It is not that it's actually the plastic section modulus, right? It is the plastic section modulus. ZE is the elastic section modulus. Exactly. ZE is the elastic section modulus. So if you are able to calculate the plastic section modulus and elastic section modulus, I can easily calculate the shape factor. So first of all, let's calculate the plastic section modulus. Now I will ask you the question, how to calculate the plastic section modulus. Before calculating the plastic section modulus, I need to find the location of the plastic neutral axis. Okay. How to locate the plastic neutral axis? Anyone? How to locate the plastic neutral axis? Anyone? How to locate the plastic neutral axis? This is actually a question. Here in this question, I can extend it. Location of the plastic neutral axis will be on the top flange, will be on the web, will be on the bottom flange. Where will be the location of the plastic neutral axis? Anyone? We have studied it in the yes, exactly. We have studied this. Plastic neutral axis divide the entire area into two equal parts, right? Plastic neutral axis divides the entire area into two equal parts. No, that is actually yes. That's the reason why it is also known as equal area axis. So where it will be? That's my question. Will it be there in the top flange, or will it be there in the web, or will it be there in the bottom flange? Where will be the location of the plastic neutral axis? Anyone? Where will be the location of the plastic neutral axis? Anyone? Location of the plastic neutral axis. For that, there is one detail given. Total area of the Total area of the section is given as 40 centimeters square. So we know half of the area is around 20 centimeters square. Right, so here we are given with 40 mm, right? We are given with something like this, 40 mm. Okay, let's do one thing. I'm going to convert it as 4 centimeter, and this is also 4 centimeter. Tell me, what is the area of the top flange? Area of the top flange. What's the area of the top flange? Area of the top flange is 4 into 4, that is 16 centimeters square. Tell me, where will be the location of the flange? Can it be on the top flange? Can the on the top flange? No, it cannot be. Why? Because even if it is there here, it is not splitting the section equally. On the top of the equal area axis or plastic neutral axis, it is 16 centimeters square only. So which means plastic neutral axis should be somewhere in this web, right? Plastic neutral axis somewhere here. So I'm going to denote it. I'm going to name it as equal area axis. This is equal area axis or plastic neutral axis. Both are same, right? It will split or it will convert the area into two equal parts. Fine. But now I have to locate it. What I'm going to do is I'm going to assume that this equal area axis is at a distance y from the top of the flange, top of the bottom flange. Let us locate the location. Let's find the location of the equal area axis from the bottom. How to do that? We know that this area here, what will be the total area here? The area below the plastic neutral axis will be equal to 20 centimeters square. Why? Because equal area axis is dividing it into two parts, right? Equal parts, two equal parts. Or I can write it like y into 1 plus this area is calculated now, y into 1 plus 16 mm, so 160 mm, or I'm going to consider as 16 centimeter. I'm going to convert everything into centimeter, okay? Why? Because it will make our calculation a bit simpler, right? It's actually your choice. You can convert, you can use millimeter also, but I'm considering it as centimeter here. So that will be a bit easier for me, right? So 16 into 1 will be equal to 20 centimeters square. From this y into 1 will be equal to 4. From that y is equal to, I can say 4 centimeter. What's the meaning of it? What's the meaning of it? Equal area axis will be at a distance 4 centimeter from the top of the flange. Equal area axis will be at a distance 4 centimeter from the top of the flange, top of the bottom flange. This will be our equal area axis. Now what we have to do? We need to calculate the plastic section modulus. How to calculate the plastic section modulus? Yes, I need your answers. How to calculate the plastic section modulus? Yes, very good. Plastic section modulus, or I can write like ZP. Plastic section modulus ZP will be equal to A1 Y1 above the neutral axis, above the equal area axis, plus A2 Y2, right? So which will be equal to, I need your answers. You can try this and you can get me the answers. For this, we need to see the figure. What is A1 here? 4 by 4. What is Y1? From here, what is the distance? We know this is, if this is 4, this will also be 4 centimeter. Why? Because total is 8, right? Web total depth of the web is 8. This is 4, this is 4, and this is also 4. So what is A1 here? If I'm considering it as A, this one here, A11, let us say 4 into 4, 16 mm square. What is Y1 distance there? 4 plus 2, that will be equal to 6. That's how we'll be calculating it. So above the neutral axis, above the equal area axis is very good, Vishnu. Above the equal area axis, we have two sections, right? Above the equal area axis, we have two sections. First one is this one, and this is another one, right? For area 1, what is the value? 4 into what's the distance there? Distance from this equal area axis is 4 plus 2, right? So it will be 6. Similarly, let's follow the same procedure. What is A2? A2 there will be, that's the area of the web, right? 1 centimeter is the width and depth is 4 centimeter. So let's multiply it. 1 into 4 into 2. So A1 Y1 is done, right? Plus what is A2 Y2? How to calculate it? 4 into 1 into 2 plus 16 into 1 into 4.5. You can just cross check it. You can just simply cross check it. You can just tell me whether it is correct or not. It's correct only. Just follow the same procedure, right? 4 into, here it is 4. We have 4 here. 4 into 1 into 2 here from here. And again 16 into 1. This is 4. The center is 0.5. So 4.5. So tell me the plastic section modulus here. Just multiply it and get me the answer. Come to that, Krishna. I need your help in finding all these things. It will be coming out to be 184 centimeter cube. Now you can understand why I have taken the values in centimeter. If I have taken the values, all the values in millimeter, it will be a big number, right? So that's the reason why I have considered it as millimeter. Sorry, in centimeter, but it's actually as per your convenience. You can follow your convenience, right? Okay. So you can do it as per your convenience. So this is actually our plastic section modulus. That is first part. You need to calculate the shear factor. This is also a question. Sometimes you will be asked to calculate the plastic neutral axis also. Will ask you to calculate the location of the plastic neutral axis. That's a common question. Sometimes they will ask you to calculate the plastic section modulus. It's also a question. And sometimes they will ask you to calculate the elastic section modulus, but it will be covered in strength of materials. That's also a question. Sometimes they will ask you to calculate the shear factor. Now we are moving on to that. Now we have calculated the plastic section modulus. Now we are interested in calculating the elastic section modulus, so that only we can calculate the shape factor. Elastic section modulus. Tell me how to calculate this elastic section modulus. Anyone? We have studied it in strength of materials. How to calculate the elastic section modulus? Anyone? Elastic section modulus, exactly, it is I divided by Y max. I divided by Y max. I need to calculate the I value. I need to calculate the I value. So first of all, calculate the I value here. Calculate the I value. I want you people to calculate the I value here first. I value means moment of inertia of the section. How to calculate it? Exactly. How to calculate the I value? In order to calculate the I value, first of all, I need to find the centroidal axis. In order to calculate the centroidal axis, I need to use this equation A1 Y1 plus A2 Y2 divided by A1, sorry, sigma A1, or I can say AI YI divided by sigma AI will be giving you the centroidal axis. But the problem, in this question, we are already given with the centroidal axis. It is given in our question that the centroidal axis is at a distance 5.6 centimeter from the bottom. It is already saying that this is at a distance 5.6 centimeter from the bottom. So it's already given in our question, right? Elastic neutral axis. Elastic neutral axis. Now we need to calculate the I value. Calculating the I value is actually a bit tedious process. It may consume 2-3 minutes of your time. So most probably it will be given in the question. Okay, I value most probably it will be given in the question. But if it is not given, what we will do? Again, I am going to convert this into 4 centimeter. In the question, it will be given. It is given in 40 millimeter. But for my convenience, I am converting it. Okay, you can do it as per your convenience. I don't want to see many zeros in my answer sheet. So this is 1 centimeter. This one here is 8 centimeter, and here it is 1 centimeter. I will be following this. Of course, this is 16 centimeter. Right? This is actually 160 mm. It is 16 centimeter. Right? So these are the details given. Now I want to calculate the I value. In order to calculate the I value, we need to use, sometimes maybe we have to use parallel axis theorem, I think. Right? First of all, let us take this area. What is I value? 4 into BD cube by 12 plus A1 H1 square, right? This is A1. How to calculate the H1 value? How to calculate the H1 value? Anyone tell me this? How to calculate the H1 value? Mahadeva is telling me like, sir, correct or not? What happened? Mahadeva, have you given me any answers? Have you given me any answers? Yes, I think I by Y max, right? Yes, it is correct only. It is correct only. That's what I have written it here, right? Mahadeva. This is I value. I value here is, sorry, ZV value will be I by Y max. It's correct only. It is correct. Yes. So H value, sorry, A1 H1 square, right? We are using parallel axis theorem. You have to remember it from the concepts you have studied in strength of materials. So it will be somewhat like 13. Total here is 13, right? Total here is 13. The total value, total depth here is 13. 13 centimeter. Right? I need this distance. How to calculate it? I know this value. What is this? This is 2 centimeter. Total is 13. How to calculate it? 13 minus 5.6 minus 2. This whole square. This is for that rectangular section. Similarly, 1 into 8 cube divided by 12. That is BD cube by 12. So I am getting your answers. The value is correct or not? 9.507. Let me check with others' answers here. Let me check. 1 into 8. So you can proceed it further, right? 1 into 8 plus A1 here is 1 into 8. H1 square, I think it is 5.6. Total is okay. I think it is 0.6. You can confirm this. Plus 16 into BD cube divided by 12 plus A1 H1 square, right? A1 there is 16 into 1 into 5.6 minus 0.5, the whole square. So this will be the I value. Total, I am going with Mahadeva's answer. You can confirm this. Yes, you can confirm this. Very good, Madhav. You're right. This will be 950.92 or 72, something like this. I'm going to consider it in 9 centimeter cube. This will be the I value. 950.72 centimeter cube will be the I value. You can just convert, you can just consider, you can calculate the later stages. No issues are there. But what you have to understand here is, most of the times, if the question is a bit lengthy, it will be given with all the values. I mean, I value will also be given in the question. Instead of the central axis, it will be given with the I value directly. Here, I want you people to understand this. In this case, we have to use parallel axis theorem. We are using I value. We are calculating the I value here. And now I need to calculate the Z value. You can confirm this answer. Okay. Yes, exactly. You are right, Mahadeva. So Z right? That is elastic section modulus. How to calculate it? I divided by Y max. So I value I have already calculated it. What is I value there? I value there is 950.72. Right, divided by Y max there. What is Y max there? What is Y max there? Anyone? What is Y max there? What is the Y max value? It is 5.6 centimeter, right? Anyone? Centimeter is 4. What is it? 5.6 centimeter? Anyone? The question it is saying that the question, this is a possible mistake. In the question they have told you that it is from 56 mm from the bottom. We'll be focusing on that digit only. That's an error. It's not 5.6. It's actually distance to the extreme fiber. Distance to the extreme fiber is somewhat 950.72 divided by 7.4. Total is 13. The answer here. What's the answer here? Exactly. Very good. Very good. What's the answer here? What's the D value? D value. I need your answers and give me the answer in centimeter cubes, right? cm cube. What's the answer here? You'll be getting it as 128 point something, right? Yes, 128. Yes, 128.50 centimeter cube will be the Z value, right? So now we can calculate the shape factor values. Shape factor here, that is SF, here will be equal to, I think the ZP value was around, ZP value was somewhat around 184 divided by 128.50. You will be getting it as 1.428. That will be your shape factor. This will be the shape factor value. So this is how we'll be calculating. We have taken around 10 minutes time here in this question, but in the examination now, you will not be given with this much lengthy question, but I have told you enough concepts here. Different concepts were discussed in this question, right? The question was to calculate the shear factor, but in this question, we have calculated the location of the plastic neutral axis. What was the location? We know how to calculate it, how to find the location of the plastic neutral axis. We have defined the shape factor. And we have learned how to calculate the plastic section modulus, and we know how to calculate the elastic section modulus. We have calculated the I value, and we have calculated the shape factor. Now I am going to tell you some important things here. We need to remember, of course, we cannot remember the shape factor for this value. Why? Because if the one dimension is changing, then the entire shape factor value will be different. But shape factor value for rectangular section, you need to remember. Shape factor value for circular section, you need to remember. Shape factor value for tubular circular sections is somewhat like this. You have to remember. Tubular section, you have to remember. Shape factor value for triangle, you need to remember. And sometimes shape factor value for diamond, you have to remember. And shape factor value for, let us say, I section. About the major axis, you have to remember. Somewhat like this, I section. Let me I will ask you this. Okay, I need you to give me the answer here one by one, and give me the answers here. What is the shape factor value for a square or rectangle? What is the shape factor value for rectangle? I need you to give me the answers here. Exactly, it is 1.5. What is the shape factor value for circle? Solid circular section. Okay, that should be the definition there. Exactly, it is 1.67. What is the shape factor value for this tubular section or tubular section? What is the shape factor value? Circular tube section. Yes, perfect, is 1.27. And for triangular section, the value is, yes, please comment the answers there. X, it is 2.37. Perfect, perfect. And for diamond section like this, the value is 2.0. And for I section like this, what is the value? 1.12. This is about the major axis. Okay, 1.12 to 1.14. And if you're having an H section like this or about the major axis, what's the value? The value will be 1.55, right? Remember all these values. All these values are important. All these values are important. Remembering this is very, very important, and remembering this is recommended. Okay. So with this, let's, yes, very good, Kushbu. Very good, very good. So remember all these things, okay? It's a circular, tubular section, triangle, and diamond sections. What if the triangle is assigned in this way? What if it is mentioned in this way? How? So this is how I am going to write the triangle. Then what will be the shape factor here? Anyone? Shape factor here. Shape factor here. Anyone? It will also be 2, right? You can check this ones, okay? You can just check these ones. We are habituated in, we know how to, the shape factor value of triangle, this one. What will be the shape factor value here in this case? This I know, that is 2.34. What about this one? Sorry, is it 2.34 or is it something else? That's my question here is. Okay, Pushpuja is saying that it is 2. Okay, is it 2 or 2.34? That's my question here is. You can just tell me the answer in the comment section, or in the now also you can tell me. I will put the answer after the session. Okay. Okay. So it will be 2. Yeah, it will be 2. You can check this answer. Okay, you can check this answer. So next one more question on this. One more question on this. Go through this question once. Yes, because you are right. That is 2 only. For a triangle like this, it is 2.34. For a triangle in the other way, it is 2 only. So go to this question once. Everyone, go to this question. Very, very important. It's almost an MSQ question. Go to this. It's an MSQ question. I'm mentioning it here. It's an MSQ question. Get me the answers here. Read the question properly and give me the answers. That's what I want to do. I want you people to do. Yes, you people are trying, right? I'm assuming that you people are trying this question, right? So first of all, I need you to tell you what is this plastic hinge or length of the plastic hinge. So consider a simply supported beam. So we are given with a simply supported beam here. Very good. Length of the beam is given L. It is subjected to a uniformly distributed load. Okay, the loading is given there, that is uniformly distributed load. So which among the following is or are correctly matched regarding length of the plastic hinge for different cross sections? So we are given with different cross sections: rectangular, solid circular, triangular, diamond. We are given with different sections, and we are asked to calculate the length of the plastic section. That's what we are asked to calculate. Now, first of all, we need to understand what is this plastic hinge, right? So first of all, let us understand that. Suppose I'm taking a beam here. I'm not taking the entire beam. I'm taking a bit of the beam, right, in the middle, right? So suppose there is a load acting, which is a concentrated load, concentrated increasing load, right? I'm increasing the magnitude of the load, like W, 2W, 3W, something like that. So at a point of time, what happened is, at the yielding happened, right? At this point, yielding happened. Somewhere near the load, yielding happened, right? This is the point where yielding happened, right? This is called zone of yielding. Yes, exactly. Zone of yielding. I'm going to call it as zone of yielding. And see, this is yielded zone or yield zone. Exactly. This is yield zone or yielded zone. If I draw the moment, if I draw the bending moment diagram, it will be somewhat like this. Now you will be able to understand it in a better way, right? So at this point, it will be somewhat like this. So this is also extending. Okay, I'm not drawing the complete figure there. So this is the point of yielding. So there will be my, and here also there will be my. From the figure you can see it here. You can see something. What is it? The value of moment at sections adjacent to this yield zone. This is called yield zone. For a certain length here, the moment will be greater than the yield moment. What they say? In the zone of yielding, the value of moment at sections adjacent to the zone of yielding, for a certain length, the bending moment value, the moment value will be more than that of yield moment. That zone, the length of that zone is actually known as length of the plastic hinge. That's actually known as plastic hinge. But in reality, we will not be considering this. We will be considering the location of the plastic hinge something like this. We'll not be considering it as a length in one dimension. That's we'll be considering it as a point only. So it depends upon the loading conditions and it depends upon the geometry of cross sections. We have the equations, or we need to remember the equations for calculating the length of the plastic hinge for different loading conditions, for different cross sections. What is or how we can calculate the plastic hinge length? And for simply separate beams, I'm talking from this question point of view. For simply separate beams with concentrated load, the length of the plastic hinge, I am going to write it as LP, will be equal to L into 1 minus 1 by shear factor. So this will be the equation for calculating the length of the plastic hinge. For simply separate beam, if the loading is somewhat UDL or uniformly distributed load, the length of the plastic hinge will be equal to, what will be the length of the plastic hinge? What will be the difference? Yes, LP root of 1 minus 1 by shear factor. This will be the equation, right? So there will be a root. That's only difference. Exactly. Very good, Mahadeva. Right. This is the answer. This is the equation I'll be using to, or we are using to calculate the length of the plastic hinge. It's actually very good. Good. You know, this equation itself is a question in many competitive exams, especially in IAS exam and other competitive exams. Remember this equation, right? If it is UDL, there will be a root, and if it is a concentrated load, this will be the equation, right? And we have seen for different cross sections what is the shear factor. If it is not a common section, we'll be finding the shear factor first, and we will be calculating the length of the plastic hinge. That's what we are going to do right now, right? So here we are given with some questions: rectangle, circular, triangle, and diamond. So for first one, that is section A, rectangle. I'm writing it directly. Okay, LP value will be equal to L root of 1 minus 1 by SF. What is the shear factor value? What is the shear factor value? Is it, tell me the shear factor value here. It is 1.5. You'll be getting it as 0.57 L. Tell me why I'm using a root here. Why I'm using a root value here? Square root. Why I'm taking a square root here? Why? Because the loading given here is UDL, right? We are given with a uniformly distributed load here. Exactly. We are given with a uniformly distributed load. Perfect. So that's the reason why we are considering it. Similarly, you can calculate it for circular section, or we can say solid circular section. Solid circular section LP will be equal to L into root of 1 minus 1 by 1.7. The answer here, what's the answer here? It will be 0.67 L, right? Tell me this, Pushpu. Or 67 or 64, I think. 64, I think. You can confirm this answer. For triangle, for the third option, for triangle, others can confirm this answer. Pushpuja is saying that 0.59. I need you people to confirm this. L root of 1 minus 1 by triangle, it is 2.34. Yes, it will be equal to 0.76 L. Exactly. Very good, Kasturidas. And finally, for diamond section, length of plastic section will be plastic hinge is equal to L root of 1 minus 1 by 2. It will be equal to L by root 2 will be equal to 0.707 L. Right. So if you look at the options, exactly, if you look at the options, you can see that, or you can find that all the options are correct. A, B, C, D, all are correct. Okay. So here, if you, in order to get the answer, suppose this question is asked for 2 marks. In order to get this complete 2 marks, you need to pick option A, B, C, and D. Right. The answer here for this particular question will be A, B, C, and D, and their answer. Got it? This will be your answer for this question. Got the point? Exactly. Got the point? Remember these equations. Okay. Very, very important. Very, very important. Simply separate beam, concentrated load. What is the LP value? Simply separate beam, UDL. What is the, how to calculate the LP value? Remember these equations. Very, very important. Super important equation. Okay. Sometimes they will directly ask you these equations. Sometimes they will ask you calculate the LP value for cross section, for rectangular or solid circular, for triangular, for tubular sections, for I sections. All these things will be given, and you will be asked to calculate the values. Okay. Okay, fine. Let's go with the next question. Go with this question. This is the question given. I need you people to calculate the collapse load for the beam shown below. You are asked to calculate the collapse load. Hi Gayatri. Yes, we need you people to calculate the collapse load here. Try this once. It's very important, super important, very, very important. Calculate the collapse load here. In order to calculate the collapse load, first of all, we need to identify, there are some prerequisites. First of all, we need to calculate, yes, exactly. We need to calculate the degree of static indeterminacy. I will tell you why. What is the degree of static indeterminacy? We have already discussed how to calculate the degree of static indeterminacy in GATE Syllabus session of structural analysis. How to calculate the DS of the beam. When you are having a beam, think about the loading conditions. Here it is vertical loading conditions, R minus S. Remove the horizontal reactions, right? Total number of reactions, 2 here, 1 here, 1 here. Total number of reactions will be equal to 4. Equilibrium equation will be equal to 2. That is 4 minus 2 will be equal to 2. This will be the exactly. Yes, exactly. This is DS value. 4 minus 2 minus 2. Sorry, 4 minus 2 will be equal to 2. That is the degree of static indeterminacy. Tell me, how many number of plastic hinges are required to form a mechanism? This is also a question. The number of plastic hinges. Number of plastic hinges to form a mechanism. How many plastic hinges are required? Remember this, it will be equal to. It will be equal to ds plus 1 is equal to 3. ds plus 1 is equal to 3. And we need to calculate the number of possible locations. Number of possible locations of plastic hinge. What are the possible locations of the plastic hinge? Tell me where plastic hinges will be formed. I am going to name A, B, C. Okay, let's write like D, E, F. Tell me the locations of plastic hinges where plastic hinge will be formed. Tell me at point A, will plastic hinge be formed there? Yes, plastic hinge will be formed there. At D, plastic hinge will be formed. At E, of course, plastic hinge will be formed. B, plastic hinge is also a possible location of the plastic hinge formation. F, there also plastic hinge can be formed. And what about C? At C, there is no possibility of forming a plastic hinge. So what are the locations of the formation of plastic hinge? Anyone? How many locations are possible? How many locations are possible here? At C, there will not be any plastic hinges. So where the plastic hinges will be formed? Yes. What are the possible locations? Possible location of the plastic hinges. See, at fixed ends, you can comment it there. Fixed end, there will be plastic hinges. Intermediate joints. At intermediate joints of continuous beams, there will be plastic hinges. Or rigid joints in a frame. Yes, I'm helping you, Kushbu, don't worry about that. I'm providing you the details. Rigid joints of a frame. At rigid joints of a frame, there is also a possibility of formation of the plastic hinges. And at points of maximum bending moment, at points of maximum BM, or we can say zero shear force, or where the material changes. Sometimes due to the change in material, MP value will be changing to 2 MP, somewhat like this. If MP is changing to 2 MP, there will be a possibility of formation of the plastic hinge here. Okay, so where material changes or cross section changes or under point loads, these are the possible locations of the plastic hinges. Okay, these are the locations of the plastic hinges. All these at all these points, There's a possibility of plastic hinge formation. So let's go back to the question once again. I mean, now you have to think yourself, right? Just think about possible locations. Fixed end, of course, there is a possibility. Don't think that at everywhere plastic hinge will be formed. Not like that. But let's think about it. There is a chance under point load. There is a chance under point load. There is a chance. It's an intermediate joint. It's an intermediate support, or it's an intermediate joint in a continuous beam. So there is a possibility. It's also a constant load. There is a possibility. Think about the support. It's not an intermediate support. It's a simple support. So there is a possibility of plastic hinge formation at the fixed end, not at the simple supported end. So there is no possibility of plastic hinge formation here. So that's the reason why I've written there is 5 locations are possible. 5 possibility, possible locations are there for plastic hinge formation. Okay. So understood this, right? Kushbu was asking this. Clear. So now let us think, but this is not our case actually. We have to first find, I'm going to write it like this. This is also a question. Sometimes they will directly ask you, how many number of plastic hinges are required to form a mechanism? DS plus 1. Number of possible locations of the plastic hinge formation, that is 5. You have to check these conditions. But here we need to find the number of mechanisms. What are the number of mechanisms here? 1 second. I need to shift this towards 1 second. Give me 1 second here. I need some space here. Okay. Now I have to find number of possible independent mechanism. Number of possible. This is also a question. Okay. Number of possible independent mechanisms. Number of possible independent mechanisms. Can anyone tell me how to calculate this? How to calculate the number of independent mechanisms? Anyone? How to calculate the number of independent mechanisms? Yes, perfect, Krishna. It is n minus ds. N value, what is n value? N represents the number of possible locations of the plastic hinge. That is n value. N minus ds. That is n is 5. Ds there is 2. Total is 3. There are 3 independent mechanisms are possible. Mechanism number 1, mechanism number 2, and mechanism number 3. We'll find it one by one. Okay. So these are 3 questions are there. Okay. Even if you are given with a beam, there are 3 questions apart from this collapse load calculation. There are 3 questions possible. First question is what is the degree of static indeterminacy? That is a question in structural analysis. But here, number of plastic hinges to form a mechanism, that can be a question. How many number of plastic hinges are required to form a mechanism? DS plus 1. Number of possible locations of plastic hinge. Number of locations of plastic hinge formation, that is equal to 5. Number of possible independent mechanisms, that is equal to n minus ds. 3 questions, discussed in 3 concepts are discussed in 1 question. Remember all these 3, right? So let us start mechanisms one by one. This is mechanism 1, right? So I'm considering this span here. This is BC. I'm considering this span. This is BC. At collapse, the beam is going to deflect like this. At collapse, the beam is going to deflect like this. Where the plastic hinge will be formed, in this mechanism is F, right? Yeah. In this mechanism, where the plastic hinge will be formed. Let's see, will there be any plastic hinge formation? No, there will be, yes. We'll be having plastic hinges here. I'll be having a plastic hinge. I'll be having a plastic hinge here, and I'll be having a plastic hinge here, right? 1 second, let me remove this. Give me 1 second. Yes. One hinge will be formed there, another hinge will be formed there. And of course, I need to calculate the collapse load. Follow this procedure to calculate the collapse load. This is 2 meter and this is 1 meter. I'm going to take this angle as theta. I'm going to take this angle as theta. Here I'm taking it as phi, and here I'm taking it as phi. See, this angle will be different. Why? Because I'm taking this distance is somewhat different, right? This is not a symmetrical loading. If it was symmetrical loading, the angle will be, theta value will be same. First of all, delta value, we know this delta value will be equal to 2 theta, or I can say 1 phi. Right? This is 1 phi, 2 theta, right? Delta will be equal to, how to calculate theta value? Theta value will be equal to delta divided by 2. From this, I can say delta value will be equal to 2 theta for this triangle. From this triangle, I can say it is 1 phi. That's the reason why I'm writing like this. So I can say phi is equal to 2 theta. Let it be there. Okay. And at the point of plastic information, the moment value will be equal to mp. It's not my, it is mp. Here also I'll be having mp value. Here also I'll be having mp value. Now I can calculate the collapse load by using virtual work theorem. External work done will be equal to internal work. What is external work? Load into displacement. Internal work will be equal to mp into rotation. External work done will be equal to load, there is 2w into delta. Delta I can write it in terms of theta or phi. I am writing it here in terms of theta, so it will be 4w theta. So here WE will be equal to 4w theta, and WI will be the internal work done. It will be equal to mp into theta. From here I can say internal work done will be equal to mp into theta plus mp into theta plus mp into phi. So that will be the internal work done, right? So mp into theta plus mp into theta plus mp into phi. Phi I can write it as 2 theta, right? So 2 theta. Total will be equal to 4 mp theta. I can equate WE with WI. From this I can say 4w theta will be equal to 4 mp theta. From that I can easily say collapse load for this mechanism will be equal to mp. Remember this, but this will not be giving you the collapse load. Collapse load will be the minimum of all the possible mechanisms. Collapse load will be the minimum collapse load for all the possible mechanisms. You cannot directly come to the conclusion that this will be the collapse load for this beam. Right. Now I'm going to consider the next collapse mechanism here. This will be the next one. This will be the next one. Tell me the possible locations. Here hinge will be formed. Here hinge will be formed. Here also hinge will be formed. Why? Why? Because this is an intermediate support. Exactly. This is an point load. This is also a fixed end. So there will be collapse load. So there will be delta. I'm going to call it as delta 1. Here also I need to consider delta value. Some people will not be taking the delta value there under the load. That is a mistake. This is delta 2. And this is 1 meter, and this is 2 meter, and this is 1 meter. You can find it and tell me the answers here, please. I need you people to try it and tell me the answers here. How to calculate delta 1 value and delta 2 value? I need to find the angles here, right? First of all, I need to consider the angles here. This I am considering it as theta. If I am considering it as theta, here also I'll be considering it as theta. I am considering this as phi and this as phi. Exactly. Let us see. Okay, let's see, right? So here it will be like 3 theta is equal to 5. You know how I'm getting it, right? This is 3 meter, this is theta, 1 meter and 5. From this I can say 5 is equal to 3 theta. Got it? And of course there will be mp. Here also mp will be there. Here also mp will be there, and here also we can consider mp. External work done will be equal to internal work done. Correct. So external work done will be equal to, I need your answers. I need your answers. What is external work done? I need your help. Internal work done. External work done will be equal to W into delta 2 plus W into delta 1 is equal to W into theta plus W into 3 theta. Correct. So this should be equal to 4W 3 theta. Sorry, 4W theta, not 3 theta. It is 4W theta. And similarly, MP into theta, that is for the hinge at A, and MP into theta, that is for hinge at B, right? This is B, right? No. MP into theta plus MP into theta. Here we have MP into 5 plus MP into 5. MP into 5 plus MP into 5. This is the internal work done. But we have to write it in terms of theta or in terms of phi. I'm writing it in terms of theta. So phi is equal to 3 theta. I know that. MP into 3 theta. Total will be equal to 8 mp theta. If we equate internal work done with external work done, I can write it like 8 mp theta will be equal to 4 wc theta. Wc represents the collapse load. From this, collapse load will be equal to 2 mp. Getting it? Seen Krishna is giving me the answer. Krishna has Kasturidas was also giving me the answer. Yes, very good. Arjit, check your answer once. Okay, you might have done mistake somewhere. It's fine. Understand that mistake and try not to repeat it. That's what you have to do. And similarly, I can consider one more mechanism. Where I have to consider the mechanism? Here I'll be considering the mechanism. Just like I considered for the concentrated load here, I'll be considering it for here now. I'm going to call it as delta 1 now. 1 second. I'm going to call it as delta 1 and I'm going to call it as delta 2, right? This is 1 meter, 2 meter, and this is 3 meter. Now I'm going to call this as theta. Okay. I have a reason for this. You also have to do this. Why? Because it will help you a lot in minimizing many things. No, we are habituated with theta, right? That's why. It is fine, right? What are the possible locations of the plastic hinge? Here I'll be having a plastic hinge. Here I'll be having a plastic hinge. Here also I'll be having a plastic hinge. Follow the same procedure. You will be getting it as WC will be obtained as 2 MB. Right? That's actually exactly same. Loading is same. Location of the loading is same. It will be, you'll be getting the same. But have to remember, if the loading is somewhat different, then WC will be different. But here in this case, for this question, that will be same. Tell me what will be the collapse load? Will it be 2W? Which will be collapse load here? Tell me which will be the collapse load? Which will be the collapse load here? Is it MB or 2 MB? Exactly. Collapse load here will be equal to MB. Collapse load here will be equal to MB. It's not 2 MB, Gushbu, it is MP. From the possible mechanisms, collapse load is that load which will just giving the minimum. It is giving the minimum, not the maximum. If you are asking you to calculate the MP value, if they are asking you to calculate the MP value, you have to take the maximum. You have to take the maximum. Here, suppose MP will be equal to WC by 2, right? Right. Similarly to that. Here, this is minimum, and for MP, you have to consider the maximum. Go to this question. The confidence you got in solving this question, go to this question, please. I want you people to solve this quickly. In the previous question, what will be your answer? For the previous question, what will be your answer? Answer will be option B will be your answer. Option B will be your answer. Exactly. Go to this question. Go to this question, please. Collapse load for the structure shown below here is. Before solving this question, I'm going to name the section here A, B, C, D. Okay. This is 2 MB, which is not mentioned in the question, but it is 2 MB and MB. Tell me the possible locations of the plastic hinges. I want you people to give me the possible locations of the plastic hinges. Tell me this. Tell me this. Give me the points. What are the points? Possible locations of the plastic hinges. How many possible locations are there? How many possible locations are there? 1 second. Exactly. I'm giving the answers as yes. Safa is also there. Safa is giving the answer as 4. Okay, very good, super. So possible locations n will be equal to 4. What are the possible locations at A, B, C, and D? Fixed ends A and D. Under the point load B. Change in cross section or change in material C. Right? Is it clear? Yes. So 4 locations are there A, B, C, D. And what is the DS value? DS value fixed beam. Central point, point load, vertical loading condition, R minus S, R is 4 minus 2, it is equal to 2. Got it? So number of mechanisms. Number of mechanisms. How many mechanisms are possible? N minus DS. Number of possible locations, 4 minus 2 is equal to 2. Number of possible mechanisms here will be equal to 2. So let us take the mechanism number 1. I want you people to try this. I will also solve it along with you. But I want you people to solve this on your own. Okay. You can depend upon my solution, but only when you need this. First of all, let us consider it under the load. This is what is our first loading, first possible location, first possible mechanism. Hinge is possible here, hinge is possible here, and hinge is possible here as well. Right? I am considering, I need to consider theta and theta values. Theta angle will be different here. This is theta, and this is phi, and we will be having W here, and this is delta, and this is of course it is L by 3 and 2L by 3. Okay. Don't take L by 2 here. If it is L by 3, total will be 2L by 3. Remember this. Okay. Remember this. Remember this value. Of course, is very good, Krishna. Let me see whether we are correct or not. I am taking it as 5. And of course, I need to consider the MP values here. What is MP value to be considered here? Is 2 MP. Here also, for the span, for this span AC, it is 2 MP only. So here also it is 2 MP. And here also it is 2 MP. But here it is MP. This is mechanism 1. Similarly, I can draw mechanism 2 also, but before that, let us calculate the theta values and all. Let us find it first. So L by 3 into theta will be equal to 2L by 3 into 5. From this, I can say theta is equal to 2.5. Theta is equal to 2.5, or I can say phi is equal to theta by 2. Okay. So now we can calculate, yes, Saurav, very good. So now we can calculate the internal work done and the external work done. How I can do that? That's my question here. How I can do that? How I will be able to calculate the internal work done and external work done? Tell me the internal work done here. Tell me the internal work done. 2 MP theta plus 2 MP theta plus 2 MP into 5 plus MP into 5. That is the internal work done, right? Let us write 4 MP theta plus 3 MP into 5. 5 I am going to write it as theta by 2. Theta by 2. Or I can say is equal to 11 MP by 2 into theta. You can write it in terms of phi also. Whatever is convenient to you, you can do that. External work done will be equal to W into delta. As I have written internal work done in terms of theta, let us write it in write delta also in terms of theta. It will be equal to, what is that, L by 3. What is that value? L by 3. Yes, L by 3 into W into L by 3 into theta. From this, we can calculate the collapse load. Collapse load will be equal to 33 MP divided by 2L. Yes, I'll come to that. 16.5 MP divided by L. So this is the collapse load for mechanism 1. And similarly, I can find it for mechanism 2. This is mechanism 2. How to draw it for mechanism 2? What is the next possible mechanism? Next possible mechanism here is there will be a possibility of formation of the hinge at the point C. At the point C, yes. Sir, how can we know 2 MP or MP at geometry change? Yes, I'll come to that. You can just listen to this now. Okay, VK. So here, see, hinge is formed on this span AC. In that case, it will be 2 MP only. Why? Because here it is 2 MP only. I think this is clear, right, VK? VK, is it clear? Okay, please respond, VK. I think it's clear, right? Now let us go to span. Let's go to mechanism 2. Second mechanism. This will be the second mechanism. So what are the possible locations? Here hinge will be formed. Here hinge will be formed. Here hinge will be formed. Of course, it is acting exactly at the center. That is, it is L by 2. This is also L by 2. Correct or not? But the loading is acting somewhat here. Loading is acting at a distance L by 3. If loading is acting at a distance L by 3, the delta has to be considered here. L by 2 is from here to here. This is the possibility of possible locations here. Now tell me this. Here, is it 2 MP or MP? Okay. Is it 2 MP or MP? Look at the beam here. Beam at the location A. Is it 2 MP or MP? At the location A, it is MP. At the location C, it is changing the cross section, or the MP value is changing from 2 MP to MP, or we can say 2 MP values. One is MP and one is 2 MP. At what point, when the load or when the moment reaches, at what point collapse happens? Is it MP or 2 MP? Which is the weaker section? Which is a weaker one? This is weaker, right? Where the collapse will be more will happen. And at this section, when the moment reaches MP, collapse will happen. It's not 2 MP. When it reaches MP, collapse will already happen. Right? So at this location, we have to consider MP, not 2 MP. Got the point? So here also I have to consider 2 MP, and here it is MP, and here also it is MP, and here also it is MP. Okay, very good. This is also MP, and theta will be same here. Why? Because we are considering it as a center. Location of the hinge is at the center. Now it is easy for us to calculate the internal work done and external work done. Internal work done will be equal to 2p into theta, first one, and mp into theta here, and again mp into theta here, and plus mp into theta. Total will be equal to 5 mp theta will be the internal work done. I am applying the virtual work principle. You can use any theorem there. Not required. No need to discuss it here. This W, always be careful about the load value given. Sometimes will be given with 2W, sometimes will be given with 3W, sometimes will be given with W by 2. That is actually up to the question paper creator. So you have to be very careful about that. W into delta will be the value. Tell me the delta value. Is it L by 2 theta? Is it L by 2 theta? No, it is not L by 2 theta. Why? Because delta is not considered here. Delta is considered here. It will be equal to L by 3 theta, which means when we equate, when we apply the virtual work theorem, Wi will become We. We will be equal to 5 mb theta will be equal to L by 3 theta into W. From this, Wc will be equal to 15 mp divided by L. So this will be the collapse load for this mechanism. 15 mp divided by. Tell me this. So what will be your collapse load? Collapse load will be the minimum of the possible collapse load for the possible mechanisms. The collapse load will be equal to 15 mb by L or 16.5 mb by L. It is the minimum, right? So 15 mb by L will be the answer. That's how we will be calculating the collapse load for beams. Collapse load for beams. Minimum of 2. Very good. So answer here for this question will be equal to 15 mb by L, not 16.5. Okay. You have to find all the possible mechanisms and find the collapse load for each possible mechanisms and take the minimum. Right? That will be the answer. This will be the collapse load here, 15 mb by L. Hope you understood this, right? Okay, you understood this? Did you understand this? Very good. Yes, super. So go to this question. If we are discussing about beams, we cannot skip frames, right? So let's calculate it for frames as well. Follow the same procedure. Very good. Same procedure. Things will be easy for you. Follow the same procedure. Get the answers for me. First of all, DS, possible locations of the plastic hinges. Then number of possible mechanisms. Do all those things. Get me the answers. I'll be taking 15 more minutes. Okay. Our session was scheduled till 4:30, but I'll be taking 15 more minutes. Is it fine? Stay tuned. I'll be discussing 2 more interesting questions. We'll be there, right? 15 more minutes. Just 15 minutes. For 2-3 marks in GATE exam. Okay. Yeah. For this question, I will also help you. Read the question properly and get me the answers. Follow the same procedure. Don't think that it's a frame. We have decided only beams. Both are same, simple only. Concept is same. Things are very, very simple. Okay, fine. Thank you. Thanks a lot. For this, how we can solve this particular question? That's my question here is. Yes. Go for this, please. Yeah. I'll also help you in solving this. It's okay. Even if you don't solve this, even if you are not able to solve this, it's completely fine. I will be there to help you. We are given with a frame here. Of course, we are given with a frame. And here also, he is asking us to calculate the collapse load. WC, collapse load. He is asking us to calculate the collapse load here for the frame shown below, and it is given that it is equal to XMP divided by L. X is a constant, maybe. Yes, X is a constant, and he is asking us to find that. He is asking us to give that value of X. To solve this question, find the collapse load. First of all, we need to calculate the same procedure, DS value. What is the DS value? With the DS value, how to calculate the DS value first? How to calculate the DS for a frame? How to calculate the DS for a frame? 3C plus R minus 3. Internal indeterminate is 0 here. So R minus 3. P here is R here is the number of reactions. Support, fixed support, 3 reactions. Fixed support here, 3 reactions. Total number of reactions will be equal to 6. 6 minus 3 is equal to 3. That will be the DS value. Give me the number of possible plastic hinges. I'm going to name it as A, B, C, D, E. Tell me the number of possible plastic hinge formations. Tell me the locations where plastic hinges can be formed. Tell me this. Tell me total how many locations are possible. Ajit is telling me it is 3. Yeah? And Vigash is telling me ADE. Okay, only 3. Gursaj is giving me 5. Perfect, Gursaj. And Krishna is giving me the answer as 2.5. Very good. BK is telling me 5. Arjit is telling me 5. Very good. Very good. So it is very good. You got the concept, right? So at fixed support, there will be some plastic hinges. In that case, A and E will be giving you some plastic hinges. Right? There will be plastic hinges formed. Plastic hinges will be formed at A and E. At rigid joint in a frame, plastic hinges will be formed. B and D are rigid joints, so there will also be plastic hinges will be formed at B and D as well. Under point load also plastic hinge will be formed. So C is also a possible location for plastic hinge formation. Total will be equal to 5. Is it clear, everyone? Please respond. Is it clear, everyone? Possible locations of the plastic hinge. Locations where plastic hinges can be formed. It is equal to 5. Perfect. So number of possible locations is equal to 5. Perfect answer. Very good. Now I need to discuss about the number of independent mechanisms. How many independent mechanisms are possible? How many independent mechanisms are possible? How many are possible here? N minus ds, n minus degree of static indeterminacy. 5 minus 3 is equal to 2. 2 mechanisms are possible, right? What are the 2 mechanisms? First one is beam mechanism. And next one is, in case of frames, we will be considering sway mechanisms. These are the 2 independent mechanisms, not the total mechanisms. Total number of independent mechanisms. First one is beam mechanism and second one is sway mechanism, right? And along with this, we need to consider combined mechanism also. We need to consider combined mechanism as well, and we'll be calculating the collapse load for beam mechanism, sway mechanism, and combined mechanism, and we'll be taking the minimum of these 3 as the collapse load. Clear? We'll be considering the minimum of these 3 as the collapse load. So first, let's go with beam mechanism. First, let's go with beam mechanism. Okay, this is mechanism number 1. So how to do it? Can you draw that? Can you try to find the beam mechanism, collapse load for beam mechanism? I want you people to try this once. Can you draw it for beam mechanism? Can you do it for beam mechanism? Calculate the collapse load for beam mechanism. First of all, you need to consider the beam there. What is the beam element there? It is BC. Sorry, it is BD, BCD, I can say. So first of all, okay, I will also help you. Try not to look at the screen. And if you have a doubt, you can just have a look at it. Otherwise, try not to depend upon the solution which I'm going to give you right now. So this is the collapse. This is a mechanism, right? So here I'll be having a hinge. Here I'll be having a hinge. Here I'll be having a hinge. Okay, perfect. As the loading is symmetrical, this will be theta, this will be theta, this will be theta, and this will also be theta. The point load will be acting exactly at the center, that is PU. This is L and this is L. Remember, it is not L by 2, it is L and L. Sometimes, even if it is given as L by 2 or 0, L and L, some persons will be taking, some students will be taking it as L by 2 and L by 2. That is a possible mistake. You can avoid it if you are expecting this to happen. Okay, this is delta. Now everything is easier for us, right? So there will be, you need to consider MP here, right? This is MP. and this is also MP, and we'll be having MP here as well, and we'll be having MP here as well. Now everything is easier for you. Tell me the answer directly here. We don't have to calculate this. Internal work done. What is internal work done? MP theta plus MP theta plus MP theta plus MP theta. That means 4 MP theta. Perfect, Arjit. Okay, thanks for that. W, then external work done will be equal to W into delta or W into L theta. That is W L theta. From this, collapse load can be calculated as, that will be equal to 4 MP divided by L. This will be the collapse load. Perfect. Got it? Are you understanding this? Are you getting this point? How we have calculated 4 MP by L? How did we calculate 4 MP by L? How did we do that? We have taken it, right? We have equated WE with WI, external load, external work done with internal work done. That's it. That's how we'll be doing it for beam mechanism. Now let us do it for sway mechanism. That is mechanism number 2. That is mechanism number 2. You can draw it first. Try to draw it first on your own. Try not to depend upon the solution which I am giving right now. Try not to depend upon this. I need you people to try this. Try to do this, only then you will be learning. Otherwise, you will be just copying this. Right? This is what is our sway mechanism, not this one from here. This is delta 1 and this is delta 2, right? I'm considering, yes, very good. I'm considering it as 5, and here also I'm considering it as 5, right? So I'm considering this as theta, and I'm considering this as theta. Tell me the possible plastic hinges. Here one hinge, here one hinge here, and one hinge here. These are the possible locations. I know delta 1 will be equal to delta 2. Delta 1, I can say this is length L and this is 2L. So L theta will be equal to 2L phi. From this, I can say theta is equal to 2 phi. Theta is equal to 2 phi. First, this is to be done. I can represent the internal work done in terms of phi or theta. It's actually completely depending upon my choice. So here I'll be having, one second, let me cut it. So there I will be having MP. Here also I'll be having MP. Why? Because MP is not varying, right? Yes. Here also I'll be having MP. What happened, Jane? What happened? This is also MP. Got it? So now I can easily calculate the internal work done. It's a matter of seconds. Once you draw this figure, it is easy for you. Right? Now internal work done, I'll write it here itself. What is internal work done and what is external work done? Do it fast and get me the answers. Theta is equal to 2 phi. So will it be better to write it in terms of phi or theta? Will be going in for theta or phi? So it's better to go with phi, right? Yes, better to go with phi. You can write it in terms of theta also, no issues are there. Yes, internal work done, right? MP into theta plus MP into theta plus MP into phi plus MP into phi. I'll write it for you. I'll write it in terms of phi, theta. Okay, fine. So MP into, let us say 2 MP into theta plus 2 MP into phi. Phi there is, I can say, theta is equal to 2 phi. I can say phi is equal to theta by 2. But I'm going to write it as theta by 2. It will become, let us write 2 will get the answer. It will become 3 MP. 3 MP theta. Correct? It's perfect. So internal work done. The external work done. What is external work done? What is external work done? From this PU, right? Yes. In external work done, this will be PU into delta 1 or PU into delta 2. So PU into delta 1 I'll be considering. Why? Because delta 1 is in terms of theta. PU into L theta. So equate them. PU into L theta will be equal to 3 MP theta. So from this, I can say PU will be equal to 3 MP divided by L. That is the ultimate or collapse load for our, yes, exactly, for sway mechanism. Collapse load for sway mechanism. right? So I think we have considered as WC, but that's actually a mistake. That's not WC. I have to write it as PU. It's fine. We can consider it as WC also, but let us write it as PU. The load is given is PU. Okay, both are fine. No issues are there. But let us write it as PU. Now one more mechanism. We need to combine them. It's known as combined mechanism. Combined mechanism. How to go for it? First of all, let's try to draw it first. Those who know how to draw it, try to do it. Very easy actually. This is the combined mechanism. I'm going to maintain a 90-degree angle here. Okay, yeah, fine. And here you have to remember the possible locations of the plastic hinge. That's the point where you have to be very careful. So this is the load. This is delta. And this is the initial position of the frame. Hinge will be formed here. 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 At this point, hinge will not be formed. Why? Because MP will be less than, a moment here will not be equal to MB. It will be less than MB. It will be maybe MY or more than that, but less than that. Okay, so hinge will not be formed there. Remember this. So there will be combined mechanism. As we are considering combined mechanism, you will be here and you will be here as well. So this will be theta, and this will also be theta. This will be theta, and this will also be theta. And this will also be theta, and but here it will be phi. And we have to consider MP here. Everywhere it will be MP, right? MP, and here also it will be MP. MP will be there, and finally this will also be MP. I'm going to take it as delta 1. I'm going to take it as delta 2. So this is what we have to do. Now it's a matter of seconds. Once we finish this, it's a matter of seconds. WI write it and WE write it. Tell me the value of WI. I need you people to write. Tell me the value of WI and need you people to give me the value of WE. Okay. Give me the values of WE and WI there. WE and WI. WE and WI. Give me the values. Shall we go for it? I'm expecting that you people are trying this. Okay, I will also help you. First of all, let us write here WI. Let's go with WI first. WI will be equal to W theta, sorry, MP theta plus MP theta plus MP theta, again 1 P theta. Done 2, 3, 4 here, and MP phi plus MP phi. Internal work is done. I'm going to write it in terms of theta, so it will be coming out to be 5 MP theta, I think. So phi there will be equal to theta by 2, right? Yes. We'll be getting it as 5 MP theta. 5 MP theta, and external work done will be equal to 2 PU L theta, that is PU into L theta plus PU into L theta. So 2 PU L theta will be there. So from this I can say PU will be equal to 5 MP divided by 2L, or I can say 2.5 MP divided by L. Okay, 2.5 MP divided by L. From this I need the value of X there, right? And first of all I need to find the collapse load. Collapse load is mentioned here in terms of X MP divided by L. I need to represent, I need to give the value of X only here, and X here is actually taken from the collapse load. Collapse load is the minimum of all the possible mechanisms. Minimum for MB by L is there for B mechanism. From same mechanism I got it as 3 MB by L, and for combined mechanism I got it as 2.5 MB by L. Which one here is the collapse load? Which one here is the collapse load? Tell me this first. Which one here is the collapse load? Exactly. Collapse load is the minimum, right? Collapse load here is the minimum. collapse load here will be the minimum. Exactly. So collapse load here will be equal to, collapse load P will be equal to 2.5 MP divided by L, but we need the answer of, we need the value of X. Comparing this equation, this load with the load given in our question, it will be equal to 2.5. So it will be equal to 2.5. X will be equal to 2.5. That will be your answer. 2.5 will be the answer. Yes. And one more question. I need you to solve this question also. And let's discuss a question from tension member and compression member. Read this question once. It's a very interesting question, and we can expect such kind of questions in GATE exam. Okay, go through it once. Go through it once. Go through it, please. Anyone? Everyone, go through this question, please. Read the question carefully. First of all, I used to say, read the question carefully and try to understand what is given in the question. Half of the job will be done. Half of the job will be done. Understand what is given in the question and try to understand what he is asking us to find. Give me the answers. I'll read the question for you. The maximum center to center distance between the bolts in the direction of load in the steel member of thickness 15 mm will be. So what is the meaning of this? The maximum center to center distance between the bolts. What is it given? What is it given? Maximum center to center distance. What is it given? What is it given? Exactly. The pitch value is given there, right? And yes, exactly. It is a pitch value given. And we have studied this. The pitch of the member, the pitch should not be less than, yes, the center to center distance between the bolts in the direction of, pitch is defined as the center to center distance of the bolts in the direction of the load, right? And pitch shall not be less than 2.5 times the diameter of the bolts. We know this, right? But in case of tension members and compression members, the IS code recommends that pitch P value should be or should not be more than 16 times T, or thickness of the interconnected members, or 200 mm. 16 times T or 200 mm in case of tension members. It should not be less than, whichever is less. And in case of compression members, it should be 12 T or 200 mm. Exactly, right, very good, very good. In case of 200 mm, in case of compression members. 12 T or 200 mm in case of compression member, very good. You can see here in the options, this is also lesser value, has to be taken. You can see here in the options, 180 mm when members is in compression, when member is in tension 200 mm, when 240 when the member is in tension, 200 mm when the member is in compression. So we are discussing about tension and compression members, so we can completely neglect this, we can avoid this. So 16 T has to be calculated. What is 16 T? The size, thickness of the beam member is given 15 mm. 16 into 15, what's the answer here? 16 into 15, what's the answer? Is it 240? Yes, you can calculate it and tell me. 12 T, that is 12 into 15. Exactly, it is 240 mm or 200 mm, whichever is less. So what is the answer here? For tension members, it is 200 mm for tension members. What is 12 into 15? No, 12 into 15 is not 225, it is 180. Right? Yes, it's 180 mm or 200 mm. Or not? True. This is minimum is 180 mm and this is for compression members. This is for compression members. So what will be your answer? What will be your answer? Which will be the answer? Our answer will be 200 mm of tension member. Sorry for this, 200 mm of tension member and 180 mm when the member is in compression. So answer here will be equal to A and B. A and B will be the answer here. A and B will be the answer here. So such kind of questions can also be expected. So can you please explain, tell why hinge won't occur in point B in the last question? At point B, at that point, plastic moment will not be reached. MB will not be reached there. A moment, sorry, moment will not be reached to MB. 1 second. That's the end of this question. I'll give you one more question. Let's finish the session with this question. Okay. Read the question carefully and get me the answers. That the previous question was from AS code recommendations, and the question is also from AS code recommendations. Try to understand the question first. That's what I want you to do. Read the question properly and get me the answers. Understand the question, very important. Understand the question, very important, very important. It's given that, yes, it is given that built-up column, we are given with a built-up column. You know what is a built-up column, right? Columns connected with lacing system or batten systems. TSMC, Indian standard channel sections, 300 mm, placed back to back, spacing 200 mm, carries a working axle load of 1500 kilonewton. Double lacing is provided, very important, with an angle of 45 degree, and lacing member should be designed to resist an design axle load of. So how to do it? Very simple. You need to remember some basic details. First of all, let's calculate the design load there. Yes. First of all, let's calculate the design load. Why? Because the load given here is the working load. So 1.5 into 1500 will be giving you the design load. I think it will be somewhat around 2250 kilonewton, right? And we need to calculate the transverse shear there. So transverse shear in case of lacing system. What percentage will be our transverse shear? What percentage will be our transverse shear? Sorry. You are giving me the answer for transverse shear. Yes, 2.5% of design axle load. The question is not asking you to calculate the transverse shear. 2.5% of design axle load. I'm going to call it as V. Okay. It will be 2.5 divided by 100 into 2250. What is the answer here? 2250. The answer here will be equal to 56.25. I'm going with your answers. Others can confirm this. This will be the transverse shear, 56.25 kilonewton. But design axle load or force in lacing member, axle force in lacing member, that is somewhat different. Axle force in lacing member will be equal to V by N sin theta. B is the transverse shear, 56.25. For double lacing system, N is equal to 4. For single lacing system, it is equal to 2. Here it is double lacing system, 4. Angle is 45, it is sin 45. The answer will be equal to, what's the answer here now? What's the answer here now? It's 19.88 kilonewton. This will be the axle force or design force in the lacing member. Force in the lacing member will be equal to 9.88. So none will be the answer here. Answer will be equal to D. Answer to this question will be equal to D, 19.88. Read the question. That's why I told you to read the question. No, Sometimes they can ask you the transfer shear. There was a question, and many IES questions are also there. This question they are asking you to calculate the axial shear force. I mean axial force in the lacing bar, or force in the lacing bar, which is equal to B divided by N sin theta. Or here the theta value is 45. Theta value here is 45 degree. Got it? That's the end of the solution there. This question is from the lacing systems or from the build-up columns. Built-up columns. Similarly, we can get the questions from batten system also. It is also very important. That is also important. And so that was the end of our session. I think we have taken around half an hour more, but it's fine, right? Many informations at the same time. So we have discussed almost all the important concepts. Still, if you have any doubts regarding any questions in design of steel structures, you can put it in the comment section below. So I'll be having a look at it all the time. Okay, you can put all the doubts there in the comment section, and you can use our doubt solving portal also. So I'll be handling the doubts. So do best in your examination. Exams are very near. Prepare well. Prepare well. All the best. Yeah, those who are present there. Thank you. Thanks all. Yes, you are welcome. Gursas, Guspu, Vikash, Krishna, Kasturidas. All the best. All the best for your exams. Do well. Okay. Yeah. Bye.